Today let's look at solving fractional equations and literal equations where we have like a couple variables and we want to solve for one or the other. Alright, let's take a look at our first problem here. This is a fractional equation, and the key thing is get rid of the denominators and then solve for x in this case. And the way we can do that is multiply 2x minus 1 times both sides. So on the left hand side, the 2x minus 1's will cancel out, and on the right hand side you get 2 times the quantity 2x minus 1. And work that down, and we'll eventually land up with x equals 5/2. The next problem involves multiplying through by the least common multiple. In this case, it will be x times the quantity x minus 2. So take and multiply both sides by that, and on the left hand side the x minus 2's cancel out and leaving you with 3x. On the right hand side the x's cancel out, leaving you with 4 times the quantity x minus 2. Apply the distributive property, and let's go ahead and subtract 4x from both sides, and we eventually get x equals 8 as our answer. This one is fairly simple. Just make sure that when you multiply through, you multiply each term by y in this case. So you get y minus 3 equals 4y. Let's subtract a negative y from both sides, and we'll get negative 3 equals 3y, and then our y will be negative 1. Next problem here. Again, let's apply multiplying through by the least common multiple. So that is y times the quantity 2y plus 3. Do that to both sides. On the left hand side, the 2y plus 3's drop out, and you get 6y's. And the right hand side, the y's cancel out, so you get 6 times the quantity 2y plus 3. Apply the distributive property. Now let's subtract 6y from both sides, and we'll get negative 6y equals 18, and divide negative 6 into the 18, and we'll get y equals negative 3. Now this next problem involves a literal equation. It's involving Fahrenheit and centigrade. Now if you have 32 degrees Fahrenheit, that's the same as 0 degrees centigrade. If you have 212 degrees Fahrenheit, you have 100 degrees centigrade. Now let's suppose that we want to solve for centigrade and then put in a value for Fahrenheit. So let's subtract 32 from both sides, and then multiply 5/9 times each of the terms. And then let's stick in 41 degrees Fahrenheit and see what that would be in centigrade. It would happen to be 5 degrees as shown on our thermometers here. Now let's look at the area of a triangle. That happens to be 1/2 times the base times the height of the triangle. And let's apply that to the Great Pyramid of Giza in Egypt. Each side of the pyramid is a triangle. Let's look at one side of the pyramid, and let's say that I give you the area of the side of the pyramid and the height, and I ask what the base is. Well, we can solve this equation here for b. So we first multiply through by 2, and then we divide through by h. Now let me give you what the area and the height is, and we'll solve for b. So the area of the side of the pyramid is 230,275 square feet, and it's 610 feet high, and you solve for b equals 755 feet. Now let's suppose that Hilbert is at the top of a slide and Newton is the bottom of the slide here. And we know that the distance between Newton and Hilbert on the ground is A feet, and the distance Hilbert is above the ground is B feet, and the length of the side is C feet. Well, we can apply, since this is a right triangle, we can apply what's called the Pythagorean theorem. A squared plus B squared equals C squared. Let's say we know that A is 15 and B is 13. Then all we got to do is substitute those values in and solve for C. So we know that A squared is going to be 15 squared and B squared is going to be 13 squared, and that those equal C squared. So we get 225 plus 169 equaling C squared, and C squared equals 394. Now we have to take the square root of both sides, and so C equals the square root of 394. That's the length of the slide, which is approximately 20 feet.